Hi all, have a good day. I'm K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this lecture series, the next topic is basics of cellular mobile communication concepts, which comes under the fundamentals of wireless communication. First, we will see what is a cell. Actually, the geographical area is divided into small groups and each group is known as cell. So in the cellular mobile communication, you are dividing the geographical area of a particular region into several cells, and each cell will be having a antenna which will be working only for specific frequency range. In the cellular mobile communication, generally you will be representing the cell as an hexagon shape, but in reality it will not be hexagon shape. Practically it will be in irregular shape. Next we will see what is a cluster. A cluster is nothing but a group of cells in the cellular mobile communication. So the cluster size here is generally denoted by capital N, and within a cluster frequency reuse is not possible. So here it is an example shown for a cell cluster. So your 7 cells form a single cluster. So the value of capital N will be equal to 7. So each cell inside a cluster will be using different frequencies as shown here in the frequency spectrum, which is represented by different colors. So one cell uses 100 megahertz, second cell uses 200 megahertz, third cell uses 300 megahertz, like that up to 700 megahertz. So each cell is using a different frequency range from 100 megahertz to 700 megahertz. So no two cells inside the same cluster can use the same frequency. Each cell should use only different frequencies because it will cause interference. Next we will see different types of cells. There are three different types of cells: macro cell, micro cell and picocell. Macro cell, it is used for large area coverage. So it's normally used in remote areas, and since it has to cover large area, you need high power transmitters and receivers, which is used in macro cell. Next one is micro cell. So it will be used for covering only small area, say for example half a mile in diameter. It is used only in urban zones, and since it's enough to cover only a small area, low power transmitters and receivers are enough here. So when you use low power transmitters and receivers, definitely interference will get reduced by using microcell concept. Next one is picocell. It is a very small cells, and it will be used in covering tunnels, or it is used inside a building like that. Next one we will see about the shape of the cell, why we are using hexagon shape and we are not using other shapes. There are different shapes like say square, hexagon, triangle, circle, etc. So why we are choosing hexagon shape here is uh, hexagon shape, it provides equidistant antennas. That is when you measure the distance between the center of one cell and the center of the adjacent cell, the distance would be equal for all the adjacent cells from the center cell. And the radius is defined as the radius of the circle. So distance between the center of the cell radius r is root 3 r. Whereas in a square, the distance will not be equal for all the adjacent cells. And also the area of coverage is less in the square shape, whereas in hexagon shape, the area of coverage will be more. Similarly, when you use a square circle shape, in the circle, when you put adjacent circles, definitely in between you will be having gaps. So the all the entire area cannot be covered while using a circular shape. In between you will be having gaps where it will not be able to access the base station. Next one is triangular shape. The triangular shape also, the distance will not be equal for adjacent cells, and also the area of coverage is less in your triangle. So this is the diagram which shows about the distance relationship. See, if for a square pattern, if you see four squares will be having a distance of d, and the remaining four diagonal cells will be having a distance of 1.414 d, where the distance is not equal for all the adjacent cells. Whereas in the hexagon shape, if you see, the distance is d for all the cells from the center. So since the same equidistance is used, we are choosing an hexagon shape, and the area is also high for hexagon shape. So generally you are representing ideally a cell as a hexagon shape, but practically it will not be hexagon shape, it will be irregularly shaped. So this is because of the influence of the surrounding terrain or of the design by the network planners, etc. So as shown in the diagram, the irregular shape is the actual coverage area of the cell, and for ideal purposes, for explanation purposes, we are choosing it as a hexagon shape. Next one, we will see what is cell footprint. Cell footprint is nothing but the actual radio coverage of the cell. Uh, since we are practically your cell shape is irregular, so we have to find out how much area actually it covers. So that is given by your cell footprint. Irregular cell structure and irregular placing of the transmitter may be acceptable in initial design, but however, as the traffic grows, when new cells are added into the network, more channels are needed, and it may lead to inability to reuse the frequencies because of the co-channel interference. So a systematic cell planning is used here, and a regular shape is assumed for a footprint. So this is a diagram which shows the area of different shapes. So area of a triangle is 1.3 radius square. Area of a square is 2 into r square, where r is the radius, and area of the hexagon is 2.6 r square. So as I said here, the area of the hexagon is high when compared to the other shapes. Next, we will see about few assessment questions. Why hexagon shape is used to represent a cell? Yes, the answer is it covers large area, and it has equidistance from the center of one cell to all the other cells in the surrounding. Next one is, what is cell footprint? Yes, the answer is the actual radio coverage of the cell is known as cell footprint. Thank you for watching this video.